All right, so if you take an expression and the leading coefficient is something other than a 1, okay, I want you guys just to take about 2 minutes, see if you can come up with the factors here. It takes a little bit longer to test them, but as you guys work, I kind of want to see where you are, what approach you guys take. All right, so most of you are still reverse foiling. Right? You still are it's based on the relationship that the terms are still product of first, the sum of the products of outer and inner, and the product of the last. Right? And so in looking at it, most of you set forth to use trial and error, reverse FOIL. Some of you started with 2x and 2x. Some of you started with 4x and x. Okay, there's two possibilities to give you the whose factors that can equal this first term of 4x squared. Okay, now from that, there's also some different possibilities of factors that can give you 6. Okay, but since our outer and inner sum, or first of all, since our product is positive, that means the sign is the same. They're either both positives or both negatives. And since our sum is a negative, what do we know about the sign of these? No matter what, we're dealing with just negatives. Okay, so that gives us a smaller number of terms to have to test in trial and error. Listen. And then you can just find the factors of 6. So we can either have 1 and 6, 2 and 3, 3 and 2, 6 and 1. Now you really don't need those last two pairings because they're just the reverse of up here, okay, for that, but I'll leave them there anyway. For the 4x, it's the same thing, either 1 and 6, 2 and 3, 3 and 2, 6 and 1. Now, since these terms are different, you do have to have all 4 of these pairs. So we have 8 different pairs, potentially 6 if we eliminate these repeated ones, to test before we find the right answer. Okay? If you feel comfortable using trial and error, I don't care if you use it, but I'm going to show you a method that's a little bit more efficient. And there are times when trial and error works more efficiently than what I'm going to show you, but really I'll kind of point out the cases where that's true, but it's pretty much true when you have prime numbers as your first and last terms. Okay? But let's take a look at an alternate method, and then we'll come back and kind of see how the reverse FOIL or the trial and error would give us the answer. Okay? So here's a way to approach this so that you never have to waste any work. No matter what, you're going to come up with the right answer the first time through your work on it. Okay? And I'm going to base it off of, I'm going to write my expression in standard form using ax squared plus bx plus c, just so I can reference the a, b, and c, the coefficients of these. Okay? So step 1 is to take the leading coefficient and your constant and find their product. Okay, so if you find the product of the leading coefficient and the constant, so a times c, what is 4 times 6? Okay, so notice I'm going to write that product right here, and I'll usually write it under the middle term. Okay, so I'll just kind of move down, and I'll put it right underneath the middle term here. Once you find that product, you're then going to find the factors of that. Okay, so find the factors of the product from step number 1, whose sum is the middle term's value, b. Okay, so are there 2 factors of 24 whose sum is this middle term, negative 11? Negative 8 and negative 3. So again, notice I write it down just kind of like a factor tree. Okay, once you establish these 2 numbers, what you're then going to do is you're going to rewrite the middle term as the sum of the factors from step 2. Okay, and all that involves is just putting the variable on it. So our middle term was an x, so I'm just going to put an x on each of these terms. So what I've done is I've turned negative 11x into the sum of negative x, or negative 8x minus 3x. Is that still equivalent to negative 11x? Yeah, so I haven't changed anything about the problem other than just its form. Okay, and then my final step is I'm going to drop down the outer terms. So drop my first term down, drop my second term, or my last term down, and then I'm going to factor by grouping. Right, so now if I group these pairs of terms, what can I remove from the first pair of terms? What common factors? Take out a 4x, and then what am I left with? In my first term, x, and the second term, -2. Always remove the sign, so I'm removing a negative. And what common factor can I remove from my second pair of terms? Just the 3, and I'm left with a what? X minus 2. If I've done it right, I should have a repeated factor. I'm going to take out that repeated factor, x minus 2, and then the remaining factors form the terms 4x minus 3 of my second factor. Okay. So now if you look up here, the way that I did this, the 4x minus 3, I wouldn't have gotten the right answer into my second to last trial. And now it's not a guarantee. Some of you might have gotten it on your first one, second one. But the nice thing with this method, and the method is called rewriting the middle term. So this is factoring by rewriting the middle term. There's never any wasted work. Never any wasted work. You're always going to lead directly to the solution. Okay, now, what if when you were splitting the 24, so what if in step 2 here, you didn't think of it as -8 and -3, you thought of it as -3 and -8. What if you flipped the order of those? So if we thought of this as -3 and -8, we rewrite the middle term. It still has a total sum of -11x. Drop down our first and last terms and factor by grouping. And from the first pair of terms, we can remove a common factor of x, leaving 4x minus 3. From the second pair, we can remove a 2, leaving 4x minus 3. Again, it's a negative. So we do still have this common factor that we remove. And then the remaining factors form the terms x minus 2 of our other factor. And so we have our factored form. Again, no wasted work. You can choose either one. You don't have to think about it. All right, like I said, trial and error works well when you don't need to test 8 different possibilities. If all you need to do is test 2 or 3 possibilities, it's probably more efficient to use trial and error. But once again, this method will never give you a wrong answer, assuming you don't make any calculation mistakes. Okay. Either order is fine. Yeah. All right, I want you to try one more like this, please. I'd like you to see if you can try doing this by rewriting the middle term. See if you can use that method. All right, so let's look at this process again really quickly. So leading coefficient times constant. What's 18 times -2? Are there 2 factors of -36 whose sum is a -9? So a -12 and a +3. If we rewrite our middle term as the sum of those, so -12x plus 3x is still -9x. Drop our first and last terms straight down and factor by grouping. Okay. In this first group of terms, what common factors can we remove? 6x, leaving 3x minus 2. Now notice, again, you always factor out the sign. Okay, so I am going to factor out a plus. Now, is there any common factor between these last 2 terms? No. If there's not, you can do one of 2 things. Ideally, you write down just a 1. You still have to factor out the plus. It's the one time where I would suggest you write the coefficient of 1 in front like this. Just so it reminds you, you have a 3x minus 2, giving you your common factor. So pull that binomial factor out, and then the remaining terms. This allows you to see that you have a +1 as your second term of that remaining factor. And the other potential, if you don't see this, or if you're making mistakes on this portion of it, what you may want to do is just switch the order of your terms. And you may want to put the plus 3x in front and the minus 12x in the back. That way you won't have to deal with the 1 here. It'll be on the other part.